Okay, so today we're going to talk about Chapter 8. Chapter 8 is what we call conic sections. Conic sections. We will not be covering all 8.1 through 8.6. We will only be covering 8.1, 2, and 3. Okay, so the conic section. The reason why it's called conic section is because if you were to place two cones back to back in this manner, you can derive or find the three sections, the three separate curves that we'll be talking about. The first one is the parabola. So we'll be talking about the parabola, which actually you already know. So it's kind of a review, but looking at it, we're going to be looking at in a new sense. And then we have the ellipse, and then we will be talking about the hyperbolas. Okay, so these are the three things that we'll be talking about: 8.1, 8.2, and 8.3. Okay, so that's basically an outline of what we're talking about. So let's talk about parabolas. So you guys all know about parabolas. You've done them before. So if I were to ask you to graph y is equal to x squared minus 2x minus 8. Okay, this is a parabola. So how would we graph this? So like this. First of all, I need to find the roots or the x-intercepts here, the x-intercepts, the roots or the solution, right? So if I solve this, what do I get? Equal to 0. This is a quadratic formula, or quadratic, right? So 1, 1, 4, 2, positive, negative, so I get negative and positive. So this becomes x minus 4, x plus 2 is equal to 0. Therefore, x is equal to 4 or negative 2. So I know that it goes through this point and this point. Okay. I also know that it goes the y-axis, the y-intercept is that. So the y-intercept is that, which means that down here, and the parabola actually, so where would the axis of symmetry be here? The axis of symmetry is where the 2 points, where it's symmetrical across each other. So it has to be right in between here, right? It has to be right in between. So this is negative 2, this is 4, so it's going to be 1. So this would be the axis of symmetry. Your point's going to be down here. It's going to go up like that. Okay, this is what parabolas are look like, okay? So the axis of symmetry, this is what we call the axis of symmetry. These are the solutions, the y-intercept. We all know this, we've done this before, okay? So, where is this point? This point is where x is equal to 1. So when x is equal to 1, what do I get here? I get 1 squared minus 8. So I get 1 minus 2 minus 8 minus 9. So minus 9. This point we also is called the vertex. Okay, so these are things that we know. All right. Another way to look at this is we can actually solve, or we can place this standard form into a completing the square form. Yes, just when you thought you were safe, that you don't have to know anything more about it, the completing the square comes back again. So I'm going to divide this by 2. And that's right at the -1, and that's how I'm going to complete the square. If I do this out, I'm going to get what? X squared minus 2x plus 1. Okay, but what I actually have is minus 8 here. So I'm going to go minus 9, and that makes me the same. And this is where the 1 and the minus 9 come from for the vertex. Okay? So that's how we complete the square and find the parabola. Okay? So we all know how to do this. Today, we're going to introduce a new way of looking at a parabola. Okay, the parabola is going to be defined. Let's say that I had the vertex here. Okay, if this was the vertex, and something like that. We're going to define this as, we'll call this the focus, and then we're going to have the same distance away, what we call the directrix. The directrix. The directrix is a line. So if the focus was P away here, it's going to be 0 and P. Since this is P, this is going to be x is equal to, oh not x, y is equal to negative P. In other words, it is the same amount away from this point, which is called the vertex, same as it was before the vertex. Okay? So, let's use this definition. So, the definition of a parabola is that a parabola, any point on a parabola, is if you take a point here, well, let me go ahead and redraw this. If I had a point, if I had a point that looks like this, if I took a point here, the distance from this point here is going to be the same distance from the directrix. So the parabola is a collection of points that are equidistant from the focus and the directrix. So, given that definition, let me go ahead and redraw this. The focus was 0 and P. So we'll call this X and Y. We just said that the distance between the focus and this point and the distance between here and the directrix are going to be the same. So let's find the distance from the focus to here, right? The distance from focus to here. The distance formula. The distance formula says distance is equal to the square root of x minus 0 squared plus y minus p squared. So this is going to end up being x squared plus y minus p squared. Okay? The distance from here to the directrix is nothing more than the y and the y here. So it's the distance here, which is basically y. The distance from here to here is same as over here, it's p. So the distance from here to the directrix is going to be equal to y plus p. So this guy here and this guy here have to be the same. So if we go ahead and look at that, what do we get? We get square root of x squared plus y minus p squared is equal to y plus p. Okay, I'm going to try to solve for y here and find out what I get. So let's square the both sides. Y plus p squared. If I do this out, I get x squared plus y squared minus 2yp plus p squared. This guy over here is y squared plus 2yp plus p squared. So let's get both the left-hand side and the right-hand side. The left-hand side and the right-hand side both contain the y squared, so this guy goes away. I have a p squared and p squared here, so these two cancel out also. So what do I have left? I have x squared minus 2yp is equal to 2yp. Move this guy over, I get x squared is equal to 4yp. In other words, I'm going to get x squared is equal to 4py, and this is the new parabola equation for you. Okay, so this is the new way we're going to look at it. The p is the distance between the vertex and the focus, which is the same distance between the vertex and the directrix. Okay? So that's what we got there. So it is crucial, you can see, to find the parabola, to find the correct equation, that you find the value of p. Okay? And we call that the focal length. P is called the focal length. Okay? Because the vertex is a focal length away from the focus, and the vertex is also a focal length away from the directrix. And as you would guess, you can move this, translate this around. In other words, if I had the same focal length, but my vertex was going to be at H and K, okay, so that means that what I'm doing is that I'm translating this graph here so that the vertex is over there. As you would guess, it would be x minus h squared is equal to 4py minus k. And I can move it around back and forth or wherever, however I want to. Okay? So what is the focal length? The focal length is the distance between these two. As the focus gets further away from the vertex, what do you think is going to happen? My parabola that looked like this, as it goes away, is going to become like this. It's going to be sharper or pointier. Okay? So P basically is a measurement of that, because that is the focal length. All right? That is the distance between these two. As the P becomes larger, as the focus gets further away from the vertex, you're going to get a pointier looking parabola. Okay? So if you go to page 574, there are different things there. The focus, directrix, axis, focal length, focal width. Focal width. Okay, the focal width is 4p. 4p, that's called the focal width. Also, this is an equation that looks like this. Okay? It can also come down like this, right? And how would it come down like that? What would your p-value be? Your p-value would be negative. If your p-value is negative, actually the directrix would be on top over here, and your vertex would be down here, and it would come like that. Another parabola you can do is y is equal to 4px squared. I'm sorry. Y squared is equal to 4px. And that is nothing more than now it opens up this way. The parabola opens up this way. If p is negative there, then it would be opening up over here this way like this. Okay, so there are two different directions here. All right. Okay, so let's look and see what we can find. So let's go ahead and do example 1 together. We'll do example 1. Example 1 says, finding the focus, directrix, and focal width. Find the focus, directrix, and the focal width of the parabola. Y is equal to negative 1/3 x squared. So, example 1, y is equal to negative 1/3 x squared. Notice that it is not in the form that we would like it to be. This is the form that we would like it to be in. Oops, I'm sorry, 4p over on this side. So this is what we would like it to be in. It's not in that form, so we're going to have to go and change this to look like this. So all I have left here is on the x squared, which means that this guy needs to go on this side. So for that to happen, I'm going to have to multiply both sides by -3, right? If I multiply them by -3, now this guy and this guy cancels out, and I end up with -3y is equal to x squared. I don't have the 4 here, so I need to go ahead and force the 4 out. 4 -3 over 4y is equal to x squared. So that means that p, which is the focal length, is going to be -3 over 4. The focal width is 4p. So it's 4 times -3 over 4, and the absolute value of that, which is -3, so the absolute value is going to be 3. And what else did we want? We wanted the directrix and the focus. Okay, so what's the focus here? Or actually, what's the vertex here? The vertex here is 0 and 0, right? So in other words, we are still on the, this is the vertex here. Okay? And this is one of those where it's coming down because it's negative. It's coming down like that, and I want, so the focus is going to be where? P away, right? So it's going to be 0 and -3 over 4, because this was P. The directrix is going to be here. Directrix is y is equal to 3 over 4, because it's, again, it's P away from the vertex. So this would be the directrix. This would be the focus. And let's see. Okay, we're good. Good. Looks like everything's good. Okay? So another way to ask this question now, in example 2, is they're going to give you all the wording, and you're going to have to find or tease out from the wording what the actual equation of the parabola is. So example number 2. Example number 2 says, find an equation in standard form for the parabola whose directrix is the line x equals 2, focus is -2, 0. So, they're giving me the directrix, is what? Directrix is x equals 2, not y equals 2. It is x equals 2, so that's 2. That's the directrix. And the focus is -2, 0. -2, 0. This is the focus. So by definition, the vertex has to be the midpoint of the directrix and the focus. So here is the vertex. So I know for sure that this is the vertex. And we're going to go like that. Okay, so this would be a x like that. It's one of these forms. Since the p-value is net, so it's going this way, which means that the p-value is going to be negative. And p here is going to be equal to what? Actually, it's going to be -2, right? Because from here to here is 2. So this is 4 times -2x is equal to y squared. So -8x is equal to y squared. That is going to be your answer. Okay? So that's good. And the translations of the parabola, we talked about that. You can translate the vertex however you want over anywhere you want. Okay? So actually, let's do an example that entails translating the parabola. Example number 3 says that find the standard form of the equation with the parabola with a vertex 3 and 4. So it gives you your vertex as 3 and 4. And the focus is on 5 and 4. Focus is 5 and 4. So this is 4 here. 3 is where the vertex is at. And the focus is, this is 3 and 4. 5, the focus is here. Okay? The focus is here. So this is the vertex, this is the focus, so it's going to have to be like that. What's the p-value here? The p-value is the difference between, or the distance between the vertex and the focus, which would be what? That would be 3 and 5, so the p-value is going to be equal to 2. Okay? So you started, so okay, before I do that, what do I have? I have over here the directrix, which is 2 from here. So y is equal to 1 would be the directrix. Okay? So, this is basically a form of this, where p was equal to 2. So p is equal to 2, so I'm going to get 8y equals to x squared. Now this would be the answer if the vertex was at the origin, but the vertex is clearly not in the origin. I have moved the vertex to 3 and 4. So I translated this guy 3 to the right and 4 up. 4 and 3. So I translated 4 to the right and 3 up. So 4 to the right, which means that it's going to look like that. And 3 up. So this here would be your answer. Where am I at? Okay, so yeah, looks good. Okay. So example number 4 shows us how to actually graph a parabola in your calculator. Okay, again, if you do not know how to use or graph the calculator is not going to do you a whole lot of good. So use the function grapher to graph the parabola. So they want us to graph x minus 3. So in order to graph this, put this in the calculator, this is what we call an implicit function. It's an implicit function because it doesn't tell me exactly what y is. I have to do some work. There is some work that needs to be done here to solve for y for me to put it in the calculator. So if I'm going to do that, how am I going to solve for y? The first thing I'm going to take the square root away. So I'm going to square root both sides. So I'm going to get the square root of 8x minus 3 plus or minus. Okay, now I can move the 4 over. Y is equal to 4 plus or minus square root of 8x minus 3. So this is what you want to graph in your calculator. Unfortunately, your calculator does not have a plus or minus sign. So what you need to do is graph y1 is equal to the plus, and y2 is equal to the minus, and you would graph those together. They would come together as one parabola. Okay? All right. example number 5, using the standard forms. So in example number 5, they're going to give you the parabola in a standard form, and you have to, again, change that into a vertex form, the form that we've been playing around with all day. So example number 5, the standard form they give you is y squared minus 6x plus 2y plus 13 is equal to 0. And it's about to find its vertex, focus, and directrix. Okay, so we're going to find the vertex, focus, and directrix. They want us to find these 3 things. So let's see what we can do. So this is kind of you have the x and the y's kind of a little discombobulated. So if I move the 2y over here, it's equal to 0. This looks a little better. Let's move the 6x over here because it's by itself. If I do that, I get y squared plus 2y plus 13 is equal to 6x. Okay, so now I'm going to have to complete this square on this one. So I'm going to divide this by 2. I get 1 squared. So I'm going to get the constant term that I'm going to get here is going to be 1. So I used 1 of the 13, so I'm going to have 12 left. Right? So now I'm going to move the 12 over. I get y plus 1 squared, 6x minus 12. If I move the 12 over here, y plus 1 squared is equal to 6x minus 2. Okay? So this is basically taking this guy and moving it 2 to the right and 1 down. 2 to the right and 1 down. So, again, further, it's going to look like this. I have to pull the 4 out because, remember, the form looked like this. So that's what I'm trying to find. I'm trying to find that. So if you look at that, my p-value is going to be what? That's my p-value. Okay? That's my p-value, which means, okay, so first of all, which way am I going here? What kind of, am I opening up this way, or am I opening this way? Well, I have the y is squared and the x is not, which means it's going to be opening up this way. So your parabola is going to look like this. Okay? So if I had not moved it, let's just look at this, I would have what? It's going to look like that, where my focus would have been there because it's POA. My directrix would have been here. Y is equal to negative 3 over 2. Okay? No, not Y, X. X equal negative 3 over 2. Now I'm going to move everything to the right 2 and up 1. So the vertex that was 0, 0 now becomes 2 and negative 1. The focus that used to be here, now I'm going to move this 2 to the right. So I'm going to move this 2 to the right. So I'm going to add 2. And I'm going to subtract 1 for the y. The directrix used to be here. Now I have to move that 2 to the right. So it's going to be that. So the final focus is 2 to the 7, negative 1. Directrix is x is equal to 1/2. negative 3 halves plus 2 is 1 half. Got that. Okay, real good. All right, so there you go. That is the parabola in a new way. Okay, all right. So we will continue on with the ellipsis on 8.2.